Every single day, humanity consumes over 130 million of these. It is the most dominant protein source on the planet. To the average person walking down a grocery aisle, this is a uniform, simple cut of meat sitting in plastic packaging. But moving this product from a farm to your plate within 48 hours requires a heavily guarded, zero-tolerance industrial process. This environment is a hyper-fast bio-mechanical gauntlet that serves as the central nervous system of global nutrition. This blueprint illustrates the core problem of this industry, applying mass manufacturing to living organic material. In auto manufacturing, rigid machines handle mathematically identical parts. In poultry processing, machines must account for the chaotic variability of biology. A fixed machine will fail when it meets varying biological shapes. No two organisms possess the exact same size, weight, or skeletal geometry. To reach this scale, engineers have to design machines that can instantly adapt to unpredictable structures with no room for error. The process begins under the cover of darkness. Specially designed heavy-duty transports pull into massive, highly secure, climate-controlled receiving bays. Inside, the entire sector is bathed in a specific wavelength of deep blue light. This graph tracks the physiological response to that light. Exposure to this targeted blue spectrum causes stress hormones to plummet to a flat baseline, which keeps the birds completely still. By hacking the organism's biology before a single machine touches it, the facility maintains meat quality and ensures the birds are handled ethically. Inside, the line never stops. An endless river of stainless steel shackles glides along overhead tracks, moving the product through the facility at high speed. In the defeathering tunnel, thousands of rapidly spinning medical-grade rubber fingers combine with highly precise blasts of scalding hot water to strip the exterior clean in seconds, leaving the delicate skin beneath completely intact. To solve for biological variability, the factory relies on arrays of dynamic tension sensors. These sensors feed data to multi-axis robotic arms equipped with steel blades, which move with insect-like speed to process each unit. As a unit passes, the system maps the unique skeletal structure in real time. This allows the blades to separate meat from bone in milliseconds with virtually zero waste. This real-time adaptation instantly eliminates the need for human butchers and completely bridges the gap between biology and rigid automation. The cuts move into sterile, ultra-bright inspection chambers. When processing organic material for human consumption, the margin for error is exactly zero. This animation shows multi-spectral cameras in action. As the light wave sweeps across the tissue, it renders the surface transparent, revealing internal structures. Human vision misses microscopic fragments at these speeds. The system flags hidden hazards, triggering an instant digital ejection. When a unit is flagged, a pneumatic arm fires, removing that specific piece from the line in exactly 1 millisecond. Safety at this scale depends entirely on automated optical systems that render the invisible visible. The product arrives in the packaging cleanroom. The air quality here is strictly controlled, mirroring the environment of a silicon microchip factory. Before the trays are sealed, they receive a blast of nitrogen and carbon dioxide, a process known as modified atmosphere packaging. This diagram illustrates the oxygen being flushed out and replaced. This specific gas mixture paralyzes bacterial growth and doubles the product's shelf life. This allows the facility to extend preservation without using any artificial preservatives. This single facility processes over 3 million pounds of meat every week, enough to fill the boxes that, if stacked, would tower higher than the Empire State Building. Beneath the robotics, human experts remain the final fail-safe. Food scientists and veterinary engineers run continuous swab tests for pathogens and recalibrate the AI vision systems throughout the shift. To manage the output, the facility uses biological digesters that capture and process all organic byproducts. These digesters convert that waste into biogas. Combined with the solar panels covering the roof, they generate enough electricity to power the entire factory floor. AI algorithms are also being trained to predict supply chain demands weeks in advance, aiming to eliminate food waste before it occurs. The packaged product on your table is the physical output of this integration. a system where robotic sensors and chemical engineering process biological matter at sub-second speeds to meet global demand.